Hello everyone. Mars hides a deadly secret. Mars, the red planet, may seem calm and silent, but it hides an unpredictable and potentially deadly force, windstorms. These aren't gentle breezes. Martian storms can stretch for thousands of kilometers and can engulf the whole planet. When Mars' atmosphere gets warm, strong winds are triggered, lifting fine dust particles that go everywhere. It is important to understand how the wind behaves on Mars and how it influences Mars' climate. A group of NASA researchers and scientists have been studying detailed images captured by the MRO high-rise camera, high-resolution images of the North Pole, which help them better understand Martian wind patterns. You see, in the winter, a portion of Mars' carbon dioxide atmosphere condenses onto the surface, forming seasonal polar caps. In the spring, as the sun gets higher in the sky, this ice sublimates, that means goes directly from solid to gas, and escapes to the surface through cracks. Gas and dust particles ejected through gas ducts are blown up by the wind, forming dark patches on the surface and also forming sand dunes, particularly Balkan dunes, which are crescent-shaped, and they are made of dark basaltic sand, which slides down the slit face of the dunes, clearly indicating the wind direction and strength. Learning about the wind in different Mars environments and how it forms and changes across diverse regions of Mars will help plan for future exploration. Dust can damage hardware. Solar panels can get completely covered by dust, interfering with communications, undermining the life of the spacecraft. Despite the in-depth studies based on MRO, high-rise and ingenuity data, wind formation and atmospheric conditions on Mars have become difficult to pinpoint until recently. A new research conducted by Kaoru Sato of the University of Tokyo is pointing to atmospheric gravity waves as one of the main factors that might influence dust storms on Mars. These waves play a crucial role in driving latitudinal air currents on Mars, particularly at high altitudes, which has an effect on weather events. What exactly are gravity waves? While on Earth, large-scale atmospheric waves called Rossby waves, caused by the planet's rotation, they influence the way air circulates in the atmosphere. On Mars is the gravity waves that affect the circulation of air. Gravity waves are wave patterns that can be triggered by wind flowing over mountains, forcing air upwards, or by air masses that have different temperatures and density, or by thunderstorms. So basically, when air is displaced upwards, gravity pulls it back down. And when air is displaced downwards, buoyancy, which is related to gravity, pushes it back up. This back and forth motion generates wave-like patterns that propagate both vertically and horizontally, and they play a significant role in transporting energy and momentum throughout the atmosphere. So the idea is to investigate the impact of Martian dust storms on atmospheric circulation. Dust storms dramatically alter atmospheric conditions on Mars, and they might intensify the role of gravity waves in circulation. And Sato's research lays the groundwork for forecasting Martian weather. Why are wind storms dangerous? Wind storms on Mars occur nearly every year. Most of them are moderate storms, but they can cover huge areas and last for a very long time. So acquiring data on the frequency of storms is important for robotic missions and future human exploration. Although they are not possible as terrestrial storms, they can significantly reduce the amount of sunlight reaching solar panels, hindering power generation for rovers and potentially impacting life support system for astronauts. Additionally, the fine abrasive dust can infiltrate and damage sensitive equipment, and the storms can reduce visibility, making navigation difficult and interfering with radio communication and telemetry. The formation of dust devils on Mars is similar to the formation of dust devils on Earth. The ground heats up during the daytime, warming the air immediately above the surface. This hot layer of air rises and the cooler air above falls, creating vertical convection cells. A horizontal gust of wind will cause the convection cells to rotate, resulting in a dust devil. NASA Opportunity rover was launched on July 7, 2003 from Cape Canaveral, and it landed on Mars in Meridiano Planum on January 25, 2004. Opportunity operated for almost 15 years, setting several records and making a number of key discoveries as it visited various Mars craters, as you can see on the screen. A global wind dust storm engulfed the entire planet in 2018. It started around May and it completely covered the whole planet in July. The storm significantly reduced the amount of sunlight reaching the rover's solar panels, causing its batteries to drain and preventing it from communication with Earth. Numerous attempts were made to re-establish contact, but the rover remained silent and its mission was officially declared over in February 2019. Hopefully, the continuing search for understanding wind patterns on Mars will help predict the weather on Mars. And we can build alert systems that we can put in place, and these will benefit future missions and future human settlements on Mars. Thanks for watching.